Hi, students. Today we are going to look at a very interesting topic in chemistry. Okay, the topic on the board is petroleum. All right, all right. Okay, we are going to start with the meaning of petroleum. Petroleum, we know, is a natural resources. Okay, that means they are naturally made by God. They are not human made. Okay, now this petroleum can be used to produce different products which we use in our daily life today. All right, now petroleum here is found inside the ground. Okay, the color of petroleum is dark brown. Petroleum is dark brown. It can be used to produce different products which we use in our daily life today, such as refinery gas, the gas we use at home to cook, kerosene, fuel, diesel, lubricating oil, candles, and coal tar which we use during the road construction. All these are the products of petroleum. All right. In this video, we are going to look in details how this petroleum is used to produce different petroleum fractions. Okay. Then how the petroleum is formed. Do you understand? Then the components, the mixtures that combine together naturally to form petroleum. Okay. Now let's start with the origin. Petroleum here is formed by fossil remain of dead plants and animals and marine habitats. Okay, it is formed by fossil remains of dead plants and animals in the marine habitats, which died about 200 million years ago. All right, the dead plant and animal that have died about 200 million years ago, which has been subjected to a very high temperature, to a very high temperature and pressure. Do you understand? The dead plant and animal that have died about 200 million years ago, which has been subjected to high temperature and pressure, will now convert naturally on their own into this crude oil, which I describe on the whiteboard as petroleum. All right, the name petroleum here is coined from two words. All right, the two words are petra and oleum. Okay, petra here means rock, then oleum here means oil. So it is described as oil rock. Okay, because they are produced naturally inside the ground. Okay, at a very deep part of the ground. That is where these petroleum are found. Sometimes they can be found, most times, inside rock. That's why the name is petra and oleum. Okay, now we are going to look at the components that mix together to form this petroleum. All right, petroleum here is an organic compound that contain the homologous series of alkane, cycloalkane, and aromatic hydrocarbon. All these are the homologous mixtures that mix together to form petroleum. Right? Look at the homologous Homologous mixture. The homologous mixture of petroleum. Number one is alkane. Number two, cycloalkane. Then number three is aromatic hydrocarbon. These are the homologous mixtures that mix together to form petroleum. All right. Alkane here can be ethane. Then cycloalkane here, let's say cyclohexane, can be cyclopentane. Okay. Then aromatic hydrocarbon here, we have benzene. These are the homologous mixtures, and here is the kind of examples I use to identify the alkanes, the cycloalkanes, and the aromatic hydrocarbon. Okay, we can still have naphthalene here. It must not be benzene. Okay, you can still have cyclopentane, cyclohexane, cyclobutane, and others. You can still have methane, ethane, propane, butane, pentane, and others. Okay, so all these I gave only one examples of each homologous series. All right. Now let's look at the components that are combined. All right, to form the petroleum. All right, that is to say, the fractions we can obtain during refining of petroleum. Here we have petroleum fractions, number of carbon, their boiling point. You know, during the refining of petroleum, right? Petroleum is now used to produce some other components, other organic substance, which are also very, very useful in our daily life. Okay, petroleum is used during the refining process to produce other petroleum fractions, which we use in our daily life. Okay, so but during the process of refining, they are separated with respect to the temperature, all right? Because the refining process involve a physical method which we describe as separation techniques, where the mixtures are separated with respect to their boiling point. So as the temperature increases, the components will start to evaporate, right, at different boiling points. Right? Here in the petroleum fractions, the first one we have here is refinery gas. This is the first gas to be produced during the fractional distillation of petroleum, which I said is a separation technique used to separate different petroleum fractions. All right. The refinery gas here is the hydrocarbon that contains carbon atom 1 to carbon atom 4 that mix together to form the refinery gas. This comprises methane, ethane, propane, and butane. That's why I have it here on the board as carbon number 1 to carbon number 4. These are the mixtures that mix together to form the refinery gas. And its boiling point is at a temperature less than 30 degrees Celsius. At a temperature less than 30 degrees Celsius. Then after that, the next to be refined is petrol. Petrol is known as fuel. You can call it gasoline or naphtha. You can call it naphtha. It contains carbon number 5 to carbon number 10. Then it boils at a temperature. It boils at a temperature 40 degrees Celsius to 180 degrees Celsius. Okay? It boils at a temperature. Look at the temperature here. Let me expand it here. Then it boils at a temperature 40 degrees Celsius to 180 degrees Celsius. Okay? The number 3 is kerosene. Kerosene, which can be called paraffin oil. Okay? Containing carbon atom 11 to carbon number 15. Contain carbon number 11 to carbon number 15. Then kerosene is refined at a temperature 180 to 250 degrees Celsius. This is the temperature at which kerosene is refined during fractional distillation. All right. Then number 4, we have diesel. Diesel is known as, here we have diesel, number 4. Diesel is known as light gas oil. All right. Then the diesel here contain carbon number 16 to carbon number 20. Then it is refined at a temperature 250 to 300 degrees Celsius. Okay. The number 5 here we have lubricating oil. Lubricating oil, which is also known as heavy gas oil, right? Containing carbon number 20 to carbon number 30. Then it is refined at the temperature 300 to 350 degree Celsius. Then we have the last in the list here on the board. Number 6 is asphalt or bitumen. This is the residue that remains at the bottom of the refinery tower. Okay, then containing carbon atom 30 to carbon atom 40. Okay, petroleum is the organic compound or hydrocarbons with the carbon chain from number 1 to 40. All right, it is refined at a temperature greater than 350 degrees Celsius. Okay, it is refined at a temperature more than 350 degrees Celsius during fractional distillation of petroleum. Okay, now what are the uses of these petroleum fractions? Here, let's see the uses here. Uses of the petroleum fractions. Here, for refinery gas here is used as household cooking gas in the industry and in the laboratory. Okay, you can say they are used as fuel in the industry. All right. Then, according to your past question, we were told that the preferred mixture of propane and butane mixed together to form the household cooking gas. Liquefied mixture of propane, prop for 3, then butane, but for 4 carbon atom. All right. And here we have 1, 2, 4, meaning that if you combine methane, ethane, propane, and butane, you are going to obtain this refinery gas. Like these are the components that makes up the refinery gas, meaning that refinery gas here is a mixture of methane, ethane, propane, and butane. All right, and this as a mixture is used in the industry or in the laboratory as household cooking gas. Then the next is petrol. Petrol here is used as fuel in vehicle, in truck, and in electric generator. They are used as fuel in vehicles and electric generator. Then kerosene here is used as fuel in lamp or in lantern. All these local lantern, okay, they use kerosene as fuel, okay. Then kerosene here is also used as fuel in aviation aircrafts, okay, in aviation aircrafts. Most aeroplane uses kerosene as fuel. Then diesel. This here is used as fuel in motor engines. It is used as fuel in motor engines and in electric generator and in electric generator. Okay. The next is lubricating oil. Lubricating oil is used to reduce friction in vehicle. Okay, it is used to reduce friction in vehicle, right? Then something like wax. The one that is used to reduce friction here in vehicle is grease. It's a typical popular example, grease. Okay, wax here is used in making candles. It is used in making candles. All right. Then the last on the list here is asphalt. Asphalt or bitumen here is residue that remains at the bottom of the refinery tower. Okay. And this asphalt here or bitumen, the one of the popular example here is coal tar. Coal tar, which is used in road construction. It is used in road construction. Then it is also used in coating pipe. It is also used in coating pipes. All right. All these are the fractions of petroleum, the number of carbon atoms they contains. These are the mixtures that are combined. All right. The carbon chains of hydrocarbons that makes up these petroleum fractions, and these are their different boiling points at which they are refined during fractional distillation. Then here are the uses of these petroleum fractions. The next we're going to look at now is the refining tower, okay, that indicates how these petroleum fractions are produced at different boiling points. All right. Remember, this process involves one of the physical methods of the separation techniques, which is fractional distillation, where mixtures are separated at different boiling points. Here we have petroleum, which I will describe here as crude oil. Okay, crude oil or petroleum. Okay, and here is where the heat is applied. Okay, heat is applied at this point. This is the Bunsen burner that burns at a very high temperature, which is at the range of 400 degree to 600 degrees Celsius. All right. Then, as the heat is applied, the petroleum here evaporates and migrate towards the refinery tower. This is refinery tower. Okay, so the temperature increases too high that the crude oil here, as it moves through this point where the heat is applied, is going to change into vapor. All right, it's going to change into vapor. As the temperature increases, it boils and evaporates. At this point here, the temperature here is at the range less than 30 degrees Celsius. What is refined here is refinery gas. Refinery gas, which is the simplest mixture of petroleum. I said it contains carbon 1 to carbon 4. All right. Then after that, the next is refined at a temperature about around the range of 40 to 180 degrees Celsius, and that is fuel or petrol. You can call it naphtha or gasoline, and I said contains carbon 5 to carbon 10. Then after that, the next is refined at a temperature within the range of 180 degree to 250 degrees Celsius. And that I said is kerosene. Kerosene, or you can call it paraffin oil. Okay, then containing carbon 11 to carbon 15. Okay, after that, the next is produced at the range of 250 degree to 300 degrees Celsius, and that I said is diesel. Diesel is known as light gas oil. Then it comprises of mixture of chain of carbon 16 to carbon 20. Then the next here is lubricating oil, which is refined at a temperature 300 degree to 350 degrees. And that I said is lubricating oil, which is also known as heavy gas oil. Then it contains carbon 20 to carbon 30. Then the next, which is going to be the last, is the one that remains at the bottom of the refinery tower, right? And I said that this is the residue and this is the heaviest component of petroleum. Then this is refined at a temperature greater than 350 degree Celsius. Then contain carbon chain of 30 to carbon chain 40, right? And that is asphalt or bitumen. Asphalt and bitumen are refined at temperature greater than 350 degrees Celsius, then contain carbon chain of 30 to 40, right? This on the board is all we have for now. Thank you and God bless you. Please don't forget to subscribe and share a link to your friend. I believe this video will help you a lot in your exam. Thank you.